Claim, evidence, and reasoning framework is a framework we're going to be using quite a bit in science this year, so I want to go over the general basics of how to use it and how to go about writing one. First off, we want to think about why we would want to use this protocol in the first place. Science involves asking questions, predicting outcomes, testing ideas, and explaining those results. So in order to do those things, we need to make sure we know what question we're trying to answer. We're trying to make sure we analyze our results and that we are able to give a good scientific explanation for those results. And so the framework just helps us to better understand both the problem we're looking at and to communicate our thoughts in a scientific manner. So the first part of the claim is the claim, which is the answer to the question that is being asked in the first place. The claim is written as a complete sentence. It's one sentence long. You can give some sentence starters like I believe that, or based on my observations, or the pattern shown is. But basically, you're looking at whatever question your experiment is trying to answer. Your claim is the answer to that question, not what you thought the answer would be, so not what you have in your hypothesis necessarily, but what the actual outcome is. So that is your claim. Again, it's the first part of the CER, and it is usually one sentence only, and you're not going into detail about your evidence or the data or the reasoning behind it. You're just simply answering the question. Next comes the evidence. This is the data that you actually collected. This can be in the form of data tables and graphs, but in your evidence section, it's usually a few sentences where you're going to actually talk about your data and how it supports the claim that you just made. So again, we got some sentence starters: according to the data collected, or we observed, our experiment showed, from the graph we know that, or the difference between. What's really important about this section is that you have to make sure you include the actual data itself. Don't just assume that saying, oh, there was a change is enough. You want to say what the change was between 2 points, or you want to express, how, like, what your graph is actually showing. For instance, if we were talking for the drops on a penny, you wouldn't just say, oh, there was a different number of drops for the soapy water than the plain tap water. That's not enough evidence. You would want to give the actual numbers that you collected, whether it be the individual data points or the averages. Talk about what the numerical difference between them is. All of that goes into your evidence. Now notice, I'm still not explaining the why in my evidence section. I am just giving the numerical or statistical support to say that I made a claim. I believe that soapy water, the penny was not able to have as many drops of soapy water on it than with tap water. The data showed that I had an average of 15 drops of soapy water and 35 of tap water. So you're kind of going into the actual what you collected here, but I'm still not saying why. The last part is the reasoning section, and this is where we actually go into the justification of the scientific reason behind why something happened. So we're going to justify the claim using the evidence and using scientific concepts discussed to put it all together. Okay. So again, we have some sentence starters. Really good sentence starters are in class we learned, or the evidence shows, or I know that because of. This is the why. The evidence was the how, and this is the why. This is usually the hardest part. This is where you want to get into your scientific, if you have any scientific vocabulary, this would go into the reasoning section. So again, for drops on a penny, this is where you would talk about cohesion and surface tension, get that vocabulary in there and use that to explain why your data came out the way that it did. So we're going to do a quick example. Imagine you have This, as your question, does the size of the pot used affect a plant's growth? And you have planted some plants and you're recording their height after 30 days of growth, and this is the results that you have. So go ahead and pause the video and try to complete a CER for the question, does the size of the pot used affect a plant's growth? And then we'll go through it piece by piece in just a second. So go ahead and pause the video, and then when you're done, you can go ahead and hit play. All right, so we had our question, does the size of the pot affect the plant's growth? If I was completing this, I would have a claim somewhere along the lines of, I believe that the larger the pot, the larger the plant will grow. Again, my claim is one sentence long, that is it. It does not need to go into the reason why, and it does not have to give any actual information about the data that I collected. It is just the one sentence that answers the question. In my evidence, I would have something like, according to the evidence, the plant in the 5 centimeter pot grew to 15 centimeters, the plant in the 10 centimeter pot grew to 20 centimeters, the plant in the 15 centimeter plant grew, centimeter pot grew to 30 centimeters, the plant in the 20 centimeter grew to 32 centimeters, and the plant in the 25 centimeter pot grew to 39 centimeter. As the pot size grew, the size of the plant also grew. So again, I'm giving my actual data here from the data table on the previous slide, but I'm not explaining why. I'm just giving the information, and that information is supporting the claim that I have that the larger the pot, the larger the plant. So finally, that gets me to my reasoning. I know that the size of the pot significantly affects the growth of a plant because as the size increased, the size of the plant did as well. This is because the larger the pot, the more space the plant's roots have to grow and spread out. This allows the plant to access more water and nutrients which it needs for growth. So in my reasoning section, I once again state that the size of the pot affects it. And then I say that it's supported by my data because as the pot size got bigger, the plant size got bigger. And then I give my scientific reason because the roots have space. So I'm going into my previous knowledge of plants and how they grow and what they need to grow, and use that to justify the fact that the size of the pot would affect the size of my plant. So that is how we complete the CER. So you give your claim, you state the answer to your question, you provide evidence, you give the actual data that you collected, and then you give reasoning, which is the scientific explanation behind it.